Gold sponge may look dull, but it holds incredible purity. Here's how it's transformed into a solid gold bar. First, the sponge is loaded into a crucible and placed into a gas-fired furnace, reaching up to 2000 degrees Fahrenheit. After around 15 minutes, the metal liquefies, bright, molten, and ready. Using long tongs, the crucible is pulled from the heat and tilted carefully into a graphite mold. Timing and control are critical here. Any slip affects the quality. Once cooled slightly, the mold is flipped, and the solid bar is released. It's raw, red-hot value, solid gold, refined and reborn in just a few intense moments. Modern construction thrives on high-speed recycling. This video captures the entire build of Ebi My Ik, a next-gen waste processing center, completed in just 18 months in Oberglatt. It opens on the construction site, as earth-moving heavy machinery clears 33,000 cubic meters of soil and forms deep foundations. Tower cranes rise as concrete walls grow, powered by local, circular concrete and solar panels on the roof. Reinforced slabs and vertical cores are poured and cured in sequence, forming the structural skeleton of the plant. Prefabricated elements arrive on site for rapid assembly, minimizing disruption and waste. Heavy-duty conveyor tunnels are laid early to integrate seamlessly with processing lines. Ventilation shafts and service ducts are embedded directly into the structure during formwork to reduce later rework. Within weeks, the facade panels are lifted into place, enclosing the hall to allow internal fit-outs during winter. Precision scheduling ensures mechanical, electrical, and sorting systems arrive just as the envelope is sealed. Inside, a high-capacity processing hall begins taking shape. After handoff, demolition rubble is weighed at the entrance terminal, then moves to a heavy-duty sorting excavator. This machine offers the first coarse separation before material is caked to the sizer for crushing. Next, 2 robotic arms, with 3 grippers each, take over. Guided by sensors and AI, they conduct up to 12,000 precise picks per hour, separating mineral waste from contaminants like plastic, wood, and metal. The robots operate continuously, handling pieces up to 30 kilograms, beyond safe limits for human workers. Clean processed material streams onto storage belts feeding a large stockpile capable of holding 60,000 tons of recycled secondary raw materials. The heart of Ebi My Ik lies in its closed-loop, urban mining philosophy, turning mixed demolition into high-grade construction aggregates rivaling virgin materials. With a production rate around 200 T per hour, the plant runs 24/7, setting new benchmarks in Swiss circular economy. Strategic roofing and integrated photovoltaic panels ensure energy self-sufficiency, while intelligent robotics maintain consistent throughput and quality. Watching raw demolition turn into precise secondary materials, a dance of machines, robots, and sustainable design. It's not just construction, it's the future of building, powered by intelligent recycling. Behind every reliable circuit is a process that starts with copper and ends in absolute precision. It begins with finely stranded, tinned copper pulled into a crosshead extrusion line. PVC resin pellets are fed into the hopper, melted, and blended with colored resin. The molten insulation flows around the conductor through a crosshead tip, forming a uniform jacket. Still hot, the wire enters a water trough, while a print wheel applies compliance markings. Laser micrometers verify diameter consistency. Spark testers scan for faults under high voltage. Cooled, tested, and reeled. Each spool is quality you can trust. Old tires don't go to waste here. They're brought back to life. After buffing, a bonding agent is brushed evenly over the buff surface. This layer acts like industrial-grade glue. It ensures the new tread will adhere firmly to the casing during curing. No skips. No bubbles. Just a flawless bond in the making. Deep below Liverpool, the George's Dockway shaft comes alive. This massive intake fan kicks in, channeling fresh air into the Queensway Mersey Tunnel, a crucial breath for safe underground travel. Loud, steady, essential. Gears like these don't happen by accident. This spiral bevel gear begins with rough-tooth machining on the DMG DMU 210, an advanced 5-axis machining center. Each pass carves out curved, angled teeth, capable of transferring torque smoothly between intersecting shafts. The multi-axis control ensures accurate geometry on every flank. Even at this roughing stage, the motion is rhythmic, almost hypnotic. All operations are handled in-house at Iwasa Tech in Tokyo, laying the groundwork for gears that power everything from heavy industry to precision robotics. Building a 16,500-ton hot forging press is no small feat. It starts with assembling massive substructures, each machined to exact tolerances. Sections are lifted and aligned with hydraulic jacks and crane systems, their sheer weight demanding precision teamwork. Cylinder units and guides are mounted next, forming the core motion system. Bolts thicker than a fist are torqued into place. Bit by bit, the skeleton becomes a machine. Watching it rise, layer by layer, is like watching industrial muscle take form. This isn't just heavy equipment. It's engineered force, built from the ground up. Spinning a 93-inch aluminum bowl from a flat sheet takes more than muscle, it takes mastery. For this project, massive chandelier light fixtures for a church sanctuary demanded ultra-large-scale metal spinning. Starting with a 96-inch square, 1/8-inch thick aluminum sheet, the material is shaped using a 140-inch spinning lathe, one of the largest in the USA. Laminated wooden mold, designed in CAD and turned in-house, guides the process. The bowl is gradually formed, layer by layer, into a seamless hemisphere. Once complete, each piece is polished and ready for final assembly. It's a rare glimpse at large-format craftsmanship, bold, precise, and purpose-built. Steel coils become shipping workhorses. This is industrial transformation in motion. At a sprawling 500-meter-long facility in Hwaju, the transformation begins. It starts with massive steel coils, cut into sheets and prepped through rust removal and priming. Workers then shape U-profiles for the base and cut sheets for doors and sidewalls. Corner posts, engineered to bear loads of up to 97 tons, are fabricated and stored for final assembly. Each container side is built from 11 welded steel panels, stretched to a total length of 11.7 meters. These walls are joined with precision welded seams, no room for leaks. The floor structure comes next. 37 steel crossmembers are welded between side rails, forming a rigid base. Door elements, front walls, and roofs are hoisted and attached, completing the basic structure. The entire shell is then blasted with fine iron particles to clean and roughen the surface before painting. A primer coat is applied, followed by a durable top coat, and dried in a heated chamber. Inspectors measure paint thickness in microns to ensure consistent protection. But what about the floor? That's built in a separate facility. Panels are laminated from 21 layers of hardwood, pressed with 16 tons of force, then baked at 135 degrees Celsius for over an hour to bond glue and wood permanently. Back on the main line, holes are drilled through floorboards and steel members, screws are installed and tightened, and sealant is applied. The Magellan logo is stenciled with speed and precision. Stickers are added every 3 minutes as containers roll down the line. Final touches include door seals, locking bars, and weight limit markings. Forced ventilation units are installed to regulate internal air and resist splash water. Each unit receives a CSC plate after passing prototype tests, including water resistance and structural load, ensuring global compliance. The floorboards are drilled to match the spacing of crossmembers, each hole aligned for perfect anchoring. Workers move quickly but methodically, ensuring that every screw bites cleanly into both steel and wood. Afterward, each joint is sealed to prevent water ingress and reduce corrosion risk during long sea voyages. Roof panels are fabricated in parallel, formed from pre-treated steel sheets and curved slightly to aid drainage. These are lifted by overhead cranes and welded seamlessly to the container's side walls. The roof welds are then inspected under high-intensity lights to reveal any surface defects. Before leaving the line, each container undergoes a final inspection. Dimensions, squareness, corner strength, and even paint color uniformity are checked. This final gate guarantees that every unit meets ISO standards and is ready to endure rough, global shipping conditions. At peak capacity, the plant produces 650 containers per day with a workforce of 1,500 across 2 shifts. Watching it all come together, from raw steel to ready to ship, is a powerful reminder. Behind every shipment lies industrial precision, relentless inspection, and an orchestra of human and robotic labor. (10) Kiernan Steel Factory Video 2019-240 https://www.youtube.com/watch?v=LF3 Soyu. Steel that supports stadiums, towers, and megafactories. This is how high-performance structural frames come to life. Inside Kiernan's factory, production starts with raw steel plate, lifted and moved by overhead cranes across multiple bays. The steel is then moved to automated cutting stations, where CNC plasma and oxy-fuel torches slice components to shape. Offcuts fall away as usable parts are conveyed for hole drilling and edge prepping. Heavy sections are CNC drilled. Pinpoint accuracy ensures bolt holes align perfectly in future assemblies. Some beams are profile cut for notching or fitting into custom geometries, all controlled via 3D modeling software. Before welding, identification tags are added to each part, ensuring traceability across the entire project. Robotic welders then take over, stacking steel with rhythmic arcs and molten beads, forging frames that will support buildings and bridges. It's hypnotic to watch automated arms trace identical weld lines across repetitive runs. Once welding is complete, assemblies are visually inspected for weld uniformity and structural alignment. Next, assembled frames travel on conveyor to a paint booth. Epoxy primer is sprayed evenly, sealing the steel against corrosion. Infrared lamps flash on, curing coatings in seconds. Immediately after, a top coat is applied, followed by another round of heat to lock in durability and color integrity. Quality checks come at every stage. Laser scanners validate dimensions before welding, paint thickness gauges confirm even coverage, and weld X-rays verify internal integrity. Only when each test is passed does the structural piece proceed to final inspection. It's not just metal, it's architectural ambition, made real. Molten steel meets relentless motion. This is how wire rods and rebar take shape at industrial scale. Inside one of the world's largest rolling mills, red-hot billets enter a series of housingless stands arranged both horizontally and vertically. These stands gradually reduce the steel's diameter while shaping it into round profiles or rebars. The design enables stable, high-speed production with minimal vibration and maintenance. Then comes the magic of slitting. As the rod narrows, it's split into multiple strands, allowing simultaneous production of smaller diameter rebar at impressive hourly rates. This keeps the mill running continuously, with less downtime between size changes. Operators monitor every transition from the control room, surrounded by real-time dashboards and thermal imaging feeds. Guided by high-speed cameras, alignment systems ensure every strand is centered before splitting occurs. Precision lubrication keeps the rollers in optimal condition, preventing wear even under extreme loads. Immediately after shaping, the glowing rods plunge into a water quenching system, WQS. The temperature profile is carefully managed throughout quenching to achieve the ideal hardness gradient from surface to core. Automated systems track every dimension, adjusting roll gaps and speeds in real time. This ensures each rod maintains exact tolerances, crucial for structural integrity. The cooled bars exit onto a long run-out table, where they're straightened, cut, bundled, and marked. Quality checks verify mechanical properties, diameter, and surface finish before packaging. Watching hot steel transform into perfect coils and bars, it's like witnessing the heartbeat of modern infrastructure. Every pass, every spark, fuels bridges, towers, and urban skylines. Raw tubes may look simple until they're bent into complex curves that power modern vehicles. Stainless steel tubes are fed into a CNC pipe bending machine where servo-controlled arms apply just the right pressure and angle. Each movement is calculated, performing precise exhaust curves for automotive use. Real-time sensors verify alignment and curvature throughout the process. There's no guesswork here, only repeatable accuracy, engineered to perform under pressure. When labor runs short and product lines multiply, automation steps up. At Mount Solar, a universal robots cobot equipped with the Vectus welding tool handles a wide range of welds with quick changeovers, ideal for high product variety. Operators teach the robot by hand, physically guiding it through weld paths without complex programming. With its built-in safety system, no cage or anchoring is needed. During peak seasons, it helps mount solar triple output while reducing lead times. Welders no longer get bogged down with monotonous tasks, while clients benefit from reliable, repeatable weld quality.